All right, so chapter 9 is on transformations. A lot of you have seen this probably in your 7th grade Common Core math. This is on reflections, translations, rotations, and the coordinate plane. So a transformation is a mapping that results in a change in the position, shape, or size of the figure. So what we're going to be doing is moving points, objects, and shapes in the coordinate plane. Translations are the easiest ones, right? This is just sliding things around. Whenever an object keeps the same exact shape, that's what we call a rigid motion. So it's a transformation that preserves distance and angle measures. So all the side lengths, if we were to shift a triangle around, all the side lengths and angles would remain the same. And it doesn't necessarily mean that orientation remains the same, right? But all angles and side lengths are the same. So distance and angle measures. The image is where we end up with a transformation, where we end up. The result of the transformation, the spot we land on. And the pre-image is just our original figure, or the starting point for our transformation. And what we're going to focus on today is translations. Translation is a transformation that maps all points of a figure the same distance in the same direction. And the shorthand notation for a translation is this. Right? We're going to use a big T. And the first number is going to tell me left or right. And then the second one is up or down. Left or right, and then up or down. So for example, if I had something like t -2, 3, this would tell me I take each point of the figure, or each vertice, or the point itself, and move it 2 to the left, and then 3 up. Okay. First one tells me I'm going to the left, 2. Second one, up 3. All right, so these are pretty easy. If 4, 3 maps onto 7, 9, then 12, 10 maps onto what? So to get from 4 to 7, I have to add 3, right? So to get from 12 to 15, I would also add 3. So that would go 15. And we're going to do the same thing with this one right over here. So this guy, we're going to, from 3 to 9, add 6. And add 6, and we get 6. There's our point we end up. Take a second, try B on your own. So from 2 to 1, I am subtracting 1. So for here, I'm also going to subtract 1. Negative 4 minus 5, or minus 1 is negative 5. And then to go from here to here, negative 3 to 2, I'm adding 5. So I'm going to add 5. And I end up with 5. So here's our translation notation. This tells me 2 right and then 3 down. So let's use this notation to describe this translation. So here is our pre-image. And here is my image. So if the shape is the same, so it has all the same side lengths and all the same angles, we're going to say this is a rigid motion. So using the magic of the old smart work, let's check this out. So I'll trace over this in blue. And if I slide this over and it matches perfectly with this other one, it is a rigid motion. Notice all angle measures are the same and all side lengths are the same. So that is, in fact, a rigid motion. So, yes, it is a rigid motion, meaning the triangles are congruent. Okay? The rigid motions, we have figures that have all the same angles and all of the same side lengths, mean that we have congruence between the two. So let's write the translation rule. So we're going to start with big T. And then the first number is how many I'm going left or right. And the second number is how many I'm going up or down. So what I'm going to do is match up 2 of the corresponding points. So if I look, I'm going to match up this guy and this guy right there. And I'm going to see how many I'm going over. And how many I'm going to the left. So move those. I don't really like those guys right there. So let's count. We're going over 1, 2, 3, 4, 5, 6, 7, 8. Over 8. And then we're going up 1, 2, 3. There's my translation. Easy as that. So a lot of counting. Moving forward. So now we're given the notation for a translation. We want to find the image of 4, 8. This is very simple to do. All we have to do is take these numbers and add them to these guys. So I'm going to add negative 2 plus 4. I get 2. Add 4 plus 12, or 4 plus 8, and I get 12. So that's the image. We're just going that direction, both of them. So you can add those together. The way to go backwards, though, you can either subtract or add the opposites. I like to think of it when we're doing translations. If we're going the opposite direction, we're still adding, we're just going in the opposite direction. So I'm going to change the rule. If I want to do the pre-image, right, the translation would be to negative 4 now. That will take me the opposite direction and give me the starting point of that. So for this one, I can simply add those again. So negative 2 plus 2 is 0. 3 plus negative 4 is negative 1. That would be the starting point. That would be the starting point. All right, graph these points on your coordinate plane. This will be a triangle, and go ahead and connect them as well. So we have 3, 2, negative 1, 4, negative 3, 7. So it's a very narrow triangle. So graph the points. And then let's go ahead and label them. So we have A, B, and C. And we want to go ahead and find the vertices of PQR under this translation. All right, so what I'm going to do is take each of these points and I'm going to move A over to the left 2 and then down 5. There's going to be P. And then the next one, as I move B over 2, 1, 2, down 1, 2, 3, 4, 5. There's Q. And then to find R, we're going to go over 1, 2, and down 1, 2, 3, 4, 5. Here's R. And we can connect those. Notice this will be a rigid motion as well. We have the same shaped triangle as well as the same size triangle. Right? So those two triangles will be congruent. Translations always are rigid motions. Right? They always preserve the size and shape of the thing. Now let's go ahead and write the vertices of these. So P is 1, negative 3. Q, negative 3, negative 1. And R, negative 6, 2. And we could have used those same properties we used up above by adding these to each of the points to find these values as well and graphing them. But in the coordinate plane, it makes sense to just go ahead and slide one way again. Yes, sir? R. Oh yeah, negative 5. Oh yeah, I went one too far. R is negative 5. There we go. Change that. Thank you, Tim. All right, the last one. What is the rule that describes this transformation? And a few other things for notation. When we put a prime next to this, right, instead of using different letters like we did for the example above, if I put this little prime symbol, which is a little dash, almost like an apostrophe, it means that is the image, right? The pre-image always starts with just the letters themselves, and then when we use P prime, Q prime, R prime, S prime, that is the image. So all we need to do here is line up two of the points. So we have point P there, P prime there, and then let's write our translation. So first, how many am I going to the right? This is going to be positive because I'm going to the right. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going down, so the second point's going to be negative. I go down 1, 2. Negative 2. So there's our translation. So that is 9-1, and we'll do our homework assignment next week. Thank you. Thank you.